Okay. Hello, welcome to Consensus Layer Call ACDC 110. This is issue 796 in the PM repo. Here's the link. Looks relatively light, but we shall see. Got a couple of Deneb things, research spec thing. Actually, some things not on the agenda. Doncrad has some big data tests that we're going to go over as well. Okay, cool. So there are a couple of pending Deneb changes that came out of the 4844 call on Monday. This is to, and that this has parallels to the execution layer. So it's primarily updating the data structure. So adding data gas use field, the execution payload, and changing the excess data gas type from unit 256 to 64. These are both very simple. They're approved and will be merged today. The intention, barring anything unexpected happening probably on this call, is to have a release out tomorrow for the updated test nets. Does anybody, is the EIP, the related PRs for the EIP, have those been reviewed and merged, or are they still pending? Because that's kind of, we're just waiting on that to push these through.
So adding the data gas used to the header is, yeah, it's getting merged momentarily. There's a couple white space things, but OnStar just approved it, and we talked about it on the call on Monday, so everybody was okay with it. Yeah, it'll be merged, before the end of this call probably. The others,
and
the changing the size.
Okay.
Yeah, we haven't discussed that at all. That kind of came after the call on Monday, so I would like to just discuss it briefly here before moving that into the EIP.
Right. So again, that's the excess data gas going from a unit 256 to a unit 64. I think if we look at the execution layer payload, there's, I think, most fields that can fit within the 64-bit type do utilize the space savings. There's no concern that this would go in excess of 64 bits, right?
Yeah, in the PR, I had some numbers, and I think the biggest it would get is like 29 bytes, 30 bytes. Sorry, bits.
Gotcha. And this is bound generally by the supply on mainnet. If you had, some crazy amount of supply, you could break that invariant.
I would need to see where it breaks, but I think, yeah, I don't even know if with 64 bits that allows, I think that that would be more than the representable amount of way in a UN256 in general. I guess if every account has a UN256 max balance, but.
Right. Is anybody opposed to this? I think we're pretty fine on the execution, on the consensus layer.
Not opposed. I just have a quick question on the proper ordering. Is data gas used before excessive data gas? Because the consensus spec PR is different than the EIP here.
Yeah, in the EIP, it's data gas used and then excess data gas.
Okay, so the consensus spec needs to fix that.
Yeah, we might. It's not broken if we don't follow that ordering, but we very much might as well follow that ordering. Okay, I can make a note of that. Okay, cool. Is that, I don't know, is there enough execution layer representation here that we feel comfortable with changing the bit size on the payload, or do we need to have a
okay from one?
Okay. Okay, is anyone opposed? Because if not, why don't we drop it into Discord, and get this merged quickly and we can get the release out on the consensus layer. Can someone do a quick blurb on Discord to ask if any opposition? It's ceremonial. I don't think there will be any or could be any.
I'll post it.
All right, cool. Thank you. Anything else on these couple of minor changes? Great. Alex, you have an update to 4788, which is still intended to be included. Alex, can you give us that update?
Sure. So there's a PR with the change to the EIP. No changes at the consensus layer. So basically from the CL, all you're doing at this point is sending over the root itself, say in the engine API. We had discussed maybe sending the slot over and like using that to like change some of the UX from the precompile that we'll get to in a second. But yeah, that seemed a little clunky, and basically we've kind of moved away from that. So now the question is, what can we do without, say, that slot information? So the CL will send over the root, and then now the question is like, how are these roots organized? And the EIP is here for 788. This PR is 7107. And what this does is basically change this so that we basically have the timestamp and the root inside the EVM that's written to this precompile. So the state of this contract as a precompile, which you can call. And yeah, really the last question here was how we key these things, how they're organized within the state of this precompile. And there's a little bit of optionality here. Ultimately, like the simplest thing we get from the EL's perspective is we have the timestamp from the header and then now this root. And that's kind of what the EIP proposes, is just adding the root to the header as well. So you have these two pieces of data. And now the question is like, how do you write them to the precompile? What this PR does that I just posted basically writes the root, and then sort of the value to that key is the timestamp just itself. And then the question is basically, okay, is this useful to anyone? And basically what this does is say there's now a set of all the valid beacon roots. And if you know it's in the set, because you get back a actual timestamp rather than say 0 or something. And yeah, generally all of the staking pools and different people in that space I've talked to are okay with this change. Yeah, there's one maybe question around bounding the size of these things. So right now, the way it works is you would just, for every block, you would write parent beacon root, timestamp, and just keep going. Then an earlier version basically like bounded this with a ring buffer, so we might want to add that back in. Otherwise, it's looking like 80 megabytes of state growth per year, which is not nothing. So yeah, has anyone had time to look at this PR or think about these changes?
Yeah, I mean, my gut is to not have some unbounded state growth here, especially given like on the consensus layer, we have these double back Merkle accumulators and try to like keep anything unbound pretty small. I know this is relatively small, but
yeah, so another option is rather than do root to timestamp, do timestamp to root, and then it becomes much easier to handle bounding them in time. So
right, and then the impetus is on the
caller to juggle like, okay, if I'm going to approve something at this slot, then I need to figure out which timestamp that was, but that's not a huge ask.
And the people constructing transactions have access to APIs. Yeah, I guess the other thing you could have some weird like map where you have time A and time B, and you always alternate between which one you're writing to, or I guess you don't want to clear out memory like that. Never mind.
So yeah, I mean, there's like different more complicated constructions you can think of, but it's simpler to just say, for example, you could say, okay, if we want this many seconds worth of data, then basically just take the timestamp mod that, and that's that.
Yeah, I know we keep kicking this one back and forth a bit. I would imagine the execution layer, people have a bit more opinion here. I'm definitely of the, it seems like kind of just, lazy is not the right word, but if we can avoid having unbounded growth with a simple change, I would lean towards that.
Yeah. Okay. I mean, I tend to agree. There's no reason just to like have this extra thing for fun in terms of state growth. So, I'll make a pass on trying to do that and have it ready for the next awkward devs next week.
Right.
In the
Cool.
meantime, if you're listening, take a look.
Are any other comments or questions for Alex? Great. And then, Mikhail and I were discussing some stuff that comes out of 6988, which is that proposer shuffling mod that proposers can't be slashed. And it looks like it might break kind of at least a property that we have today. Mikhail, can you give us the update on that one?
Yeah, sure. So there is the 6988 EIP, which makes the slash validator not eligible to become a proposer. And if slashing happens like within an epoch, it may change the proposer set for this epoch. But currently we have this invariant that the proposer shuffling remains unchanged throughout the epoch. So this this fix may break any cache in the beacon node or in the validator client that we have on that the clients may use on the proposer shuffling for the current epoch or for the current epoch. And also it can break some tooling. So that's a question that I think it's very important to discuss before who we decide to have this change.
I'll just say right there that computing a new shuffling is very, very expensive.
Even
In
on the
this
proposer
case,
side. Sorry about that, Mikhail.
I was just gonna say that it's not like probably in this case you don't have to recompute shuffling. It's just about if a proposer that you have in this cache, one of the proposers becomes slashed, so you have to swap this proposer for a particular slot with a new one. Yeah, probably it's also computationally intensive. What worries me more is that there is a cache on, for instance, validator client side, and validator client will have to do some, additional requests every time because or otherwise we'll have to track slashings which sounds like quite an overhead for validator client.
It definitely brings more complexity. I mean, yeah, you will break for Prism. I'm speaking for Prism. You break our current safety in terms of using proposal cache. I mean, it's not doable. I mean, we can definitely fix that. So yeah, So I think that's our stance.
Yeah, I mean, my perspective is definitely realizing this like a higher complexity change than we expected a few weeks ago when we greenlit this one. So I guess where I'm at is, do we have the confidence to move forward on this, or do we want to put this in the back burner to do a deeper analysis and slot this in some other time? I guess it's not really analysis of the spec. We understand the spec. It's just how much complexity it brings into clients.
I mean, the validator client, it has to assume that the proposer shuffling can change anytime, anyway, because of reorgs. So I don't know if that's a big deal.
Yeah. Right. So
Yeah,
it's
question.
constantly reassessing.
Yeah, a question to Terence. So there is some cache that you use for that is attached to a fork, right?
Yeah.
Okay. Because I assume that probably validator client can have this type of cache. I don't know. So it's probably, yeah. Anyway,
Yeah.
probably not.
Itan brings up another interesting point. You can still propose, just not on the parent or the ancestor that had slashed you. Which in the normal case you then would be reorg, but it does bring in kind of like a weird side dynamic here. So zooming out, there are, I think there's 4788, there's 6988, there's 7045, and there's this fixed voluntary exit domain, which might have an EIP as well, that we intend to build down into the Deneb spec over the next couple of weeks to introduce these, what are relatively small features in relation to 4888, into the spec. So given that timeline, I guess we could focus on building the other three into the spec. I meant 4488. I said it out loud, Marius, and I realized it was totally wrong. But we could focus on building these other three into the spec to keep the discussion open for 6988, because this just came to light in the past 24 hours, and readdress it on a call in plus 2 weeks. So likely before that call, we'd have these other features built in for a release, and then can make the final call on 6988 at that point. Does anybody pose that? Gives a little bit of time to talk about this one, and think about the engineering implications. Okay, I see one thumbs up and hear no opposition. Okay, and that was a point I wanted to make as well. I meant to make an issue before this call tracking the features that we tend to build into Deneb from here. I did not, but I believe that list of 4 is correct. Did I miss anything? 4788, 6988, 7045, and the DAP Lion voluntary exit domain, which maybe has a number or not, I'm not certain. I'll make a tracking issue for that, and note in there that the intention is to build those down into the Deneb spec over the next couple of weeks. And we will bring up 6988 in plus 2 weeks. Please take a look at this. You know, this is moderate wrench in the intention here, or what we thought was simple here. So let's have that conversation and surface this back in 2 weeks. Any closing comments on 6988? Great. Next up is Doncred, which you're very welcome to share your screen if that's helpful. Doncred ran some big data experiments and has some stuff to show us.
Hello, can you hear me?
Yes.
All right. Can you see my screen as well?
Yeah, that's pretty small, but I imagine maybe you can zoom
Okay.
in. It seems like the aspect
Yes.
ratio is kind of crazy.
This better?
Yeah, any
change?
additional amount of zoom would be useful, but this is beginning to be readable.
Okay, let me see.
I don't know what
Can you
screen
like
you're on.
zoom in the browser?
Yeah, like
I
command or
just make the
control plus
window
or
smaller.
something.
I think that might be the easier way.
There you
Okay,
go.
that's looking good.
Good, great. So over the weekend, I did some tests on mainnet. Basically, I wanted to figure out how if we could support those blobs and how many we could do on each block. I'm going to share these as well so that you can all have a look at it. So basically,
Hey, Donkrud,
um,
are you,
yeah.
is your mic sounds not great? Are you going through your headphones?
oh, yes, I think, I hope so. Wait, let me check. Is this better?
Quieter but clearer.
Hello?
Yes, that's good.
Hello? Is this better?
Yes, yes, great.
Okay, great. Okay, so over the weekend, I did some tests where I basically created large blocks on mainnet in order to see how much data we could support. I shared the dashboards that Sam created for this just in the chat so that you can all have a look at it as well. So basically, we created blocks. Well, I mean, this is not the actual size of those blocks, but that's how much basically extra data I try to integrate into each block. I started at 128 kilobytes, went to 256, 512, 768, and 1 megabyte. So that corresponds to between 1 and 8 blobs per block in terms of amounts of data we added. What we saw was that for pretty much the whole range, the network itself was stable. Like there weren't any crazy things happening. Although I will come to that on the second test at 1 megabyte, we did see one reorg due to the late block reorg that some clients have implemented. One to start with, here is like a dashboard that Sam has created that shows how the bandwidth was on different clients, and yeah, you can clearly see that on those blob tests, the bandwidth consumed went up quite a lot. And I won't go through all, so like basically up to 512 kilobytes, like, and even 768 kilobytes, as you'll see, like everything looked very normal and stable. So this is the first 768 kilobyte test. The red markers, they are the annotations for when the blocks were sent, the big blocks. And these are block arrival times at different centuries on mainnet. And on this first test, actually for most of them, it's like even well within the noise ratio when those blocks arrive. Like, I mean, you can see that even under normal network conditions, you get blocks arriving up to 3 seconds past the slot time, and that's also what we saw during the tests. So that looks pretty good. And most of this is just completely normal. We can see, yeah, almost a very, very small decrease in the attestation scene distance and there's one decrease in attestation agreement here on the first of those blocks.
And that's head agreement, correct?
Yes, I think so. Although, like, I mean, yes, in this case it is, but that's unfortunately not what this dashboard always shows. Like when nobody agrees to the head, then the 0 apparently indicates the block before. Yeah, so that is the first 768 kilobyte tests. Second one is here. On this one, I think it looks like a bit more like there was a little bit, like maybe the blocks were a bit larger. I haven't looked at exact detail, but like, yeah, you see a little bit more of spiking, but it's still within the noise range. And yeah, and we also see a little bit more people missing the head on some of these. Overall, I would say like 768 kilobytes looks very stable to me. Like there's nothing I would be worried about in these metrics. So I think we can relatively safely go to up to 6 blobs per block. And then I also ran tests at 1 megabyte, which would correspond to 8 blobs. This is the first test, which again looks fairly okay in terms of block propagation. Well, we're sometimes spiking to 3.5 seconds here, but when you look at like the other dashboards, that's even again something that you sometimes see for not even very big blocks. But definitely some spikes in block propagation here. And yeah, you see
I think you're on the 756.
No, this is 1 megabyte, I think. Wait. Yes, this is 1
Okay,
megabyte.
got it. Sorry.
Yep. This is the first test. And yeah, you see a little bit more people not voting for the head here on some of these blocks. And then on the second test, we saw for the first time something's going wrong. So like, can actually see it here. So very nicely, like one of the blocks actually arrived more than 4 seconds into the slot time. And so it was, what actually happened is that it was orphaned. And that's like we checked, the next proposer was Prism. So I assume that what happened was that they decided it didn't have enough attestations and intentionally built on the previous block.
And it was
So-
something like they had 8% or correct head, right?
I do not know that number. Where did you get that?
I thought it was in that chat under discussion. I'd have to look it up.
Okay, I don't remember that. Okay, maybe, yeah. So yeah, it looks like this is what happened. I would say the network was still stable, but we just didn't manage to get it before that deadline. But like nothing crazy happened due to that.
Yeah, Pop
And yeah,
said
you can also
92% attested to the parent of that block and 8% attested to that block.
I see.
Which
Okay.
it shows you, something about the kind of delivery boundary.
Yeah. Actually, if someone is able to get, I haven't get, this is the slot for that. This is the orphaned block. If someone is able to get the block for the slot and could tell me how big it actually was, because unfortunately I don't have that number. I suspect that we created a block that, like some of the later blocks were actually much bigger. They were even up to 1.7 megabytes, and those made it in. So I suspect that this block as well might have been larger than we were intending, because yeah, we can't perfectly control how big the blocks are going to be that we're creating.
So given the note stock, especially the first one, is that enough? Does that give other people that want to dig into this data enough note about which slots these tests are happening on?
Oh,
Okay, cool.
yes, yeah. Here in the second, in the stock here, it has all the block and slot ranges.
Cool. So I guess some of the potential orphan blocks become harder to do historical analysis on, but if somebody
it was
wants
only
to
a single block that was orphaned. There was another actually in the second range. There's another missing block, but that validator was just offline, and so that wasn't us. It was already offline before that.
So I do think it would be valuable for if somebody wants to, or multiple people want to do more data analysis on this, rather than just looking at these dashboards, like better understand kind of the variance, better understand. I guess some of this is going to be hard to do if you don't have Sentry nodes that we're already looking at this. I guess primarily we just have chain data. Nonetheless. Cool.
Yeah, so I would say basically based on this that since this is actually quite pessimistic, like we are actually creating those huge blocks, but we decided a while ago that we're going to separate block and block propagation. And also we should consider that we were actually going through the mempool with 64 kilobyte transactions, so that added additional load that's not going to exist with the blobs, which have used the more like the less bandwidth intense mempool where like people do a pull rather than push.
Right.
So given that, I think like going to like a limit of 6 blocks and a target of 3 blobs would actually still be safe. Yeah, so that would be my recommendation based on these. And the second thing that I would maybe want to think or like recommend we start thinking about is whether the 4-second deadline for blocks is still appropriate. Because what we have done is that we have now we're adding more and more things that need to happen in this first third of the slot. Like we had this 4-second deadline originally already when we launched the beacon chain, and back then the only thing that needed to happen is the beacon block itself. And we also didn't have a 4-second deadline because we didn't reorg late blocks. And since then we have added the execution block, which now needs to be propagated and verified. We're going to add the blobs, and we are also like we have now added this kind of block slot
Poor man's block
choice
slot.
kind of through like this reorg if it doesn't have enough attestations. So I think like they're much harsher on what needs to happen in this first third, and I would think it may be a good idea to think if we want to move the deadlines around a bit in the slot. At least it would be interesting to see what we know about when like attestations happen, when aggregations happen, and maybe it makes more sense to prolong this first phase where we wait for the block and have a little bit less time for the second and third phase. Because that would give us a lot more. Yeah, first it would make the chain probably more stable, and second it would also give us make it much easier to like increase the number of blobs a little bit at least.
This is really nice. 2 points. If we're moving back times, which I'm generally positive about, what happens today is that there's like a big bandwidth spike around the time when attestations are published. And then the aggregation publishing is actually not that bad anymore because we remove duplicates much better. So that would be interesting to see, like, look at when the bandwidth spikes happen, and also in clients implement this rule that we're allowed to test as soon as we've seen the block. This kind of evens out the bandwidth profile of attestations, but I think not all clients implement it. In fact, maybe only Nimbus.
Sorry, what was that? What was the second the thing you said? Maybe Nimbus is only implementing.
So the rule for when you're supposed to publish the attestation is currently when you've seen the block or when 4 seconds have happened.
Which kind of causes potential weird race conditions, right?
Well, it causes a big burst at the 4-second mark if you don't implement the first rule, because everybody then at the 4-second mark sends an attestation, like literally the whole, well, a 32nd of the validator set, which is quite a lot of validators today. And they all just spam the network at the exact same moment. So that's bad. So if clients were to implement send attestation when you see the block or a little bit after, that would even out that flow. The second good news is that thanks to the split, we've also opened a PR on the lip2p spec, which introduces a new message that's called I don't want instead of I want. And it's basically, great, Enrico, thank you. Teco also does this even sending. The I don't want, it basically says that I don't want my neighbors to send me a particular piece of data because I already have it. So this is really good for big blocks and big blobs. So if anybody's interested in that kind of network optimizations, check out the libp2p spec repo where there is a PR up about this, which I forgot the number of, but I'll post it later in the consensus dev R&D channel.
Yeah, I'm definitely eager to see some of those types of optimizations make it through. I think they certainly complement the type of data analysis we're currently doing. Was there not a race condition problem with the releasing the attestation right when you got the block? Is that why there's some sort of like short time delay after?
There is, if you send the attestation to a client that hasn't yet processed the block,
Right.
It might ignore that attestation unless it has a queue, which queues unknown attestations for the current slot. Yeah, that race is solvable. Let's put it this way.
Mhm. I guess so. So Donker does have a concrete recommendation, which is to change this from 2.4 to 3.6. Is that in the cards? Is that is this data convincing? Is there more analysis or additional longer experiments that should be done? Yeah, just temperature gauge on that. We have some time to tune this value if there is an intention to tune the value, but we need to begin to have that conversation now. It is nice. I think one of my goals in this experiment was to see that 2.4 was safe, and I believe that we have that data now, which is good. But there's also then the question of, and what else? Conrad, for the data that's behind those dashboards, which came from the Sentries that the DevOps team is running, is there a raw version of that or an API version of that that people could do more analysis other than just look at the dashboards, or are we pretty much sure have the dashboards and that's what we got?
I don't know. I haven't looked at the raw data. But I mean, I'm sure they can provide that if you need.
Okay. I can ask them. Cool. This is awesome. I really
So,
appreciate you taking the
I
charge.
would
on
like
that.
to also because I see a lot of messages in the chat being very, oh, we should start slowly and not I have a lot of people asking me when blobs are finally coming, and there are several teams which are building products at the moment, really needing this. I think people underestimate how much this is going to be used and how big this is going to be. I
To
really
me,
think
that's an argument to start slow.
Why?
For the simple reason that the data like this experiment, it shows behavior under unsustained load, right? And it's already
It is
showing a
sustained.
bit of effects.
It's sustained.
Yep.
It's 10
For
blocks,
10
10 blocks
slots.
in a row.
Okay,
There's
okay.
10 slots in
Then
a row.
that's actually a lot
with-
better than I thought.
Oh yeah.
And
Oh, nice.
I
we
was really
could
pummeling it.
consider trying to do a longer one, although it just becomes very expensive. If there's value in attempting to do more repeated experiments or longer experiments, we can attempt to do so. Okay. I do believe there's also kind of a side conversation going on the ever pending honest block reorgs specification, and if there should be additional changes about the percentage of attestation seen and potentially stronger circuit breaking mechanisms, so that, you know, in the event that every block is taking more than 4 seconds for whatever reason, you get more than 50% of the blocks. Is Hotez on the call? No. I believe on Prism, there's some sort of justification circuit breaker that was said in the chat. Does that mean like if there's not sufficient blocks to justify, they would actually circuit break and stop doing the reorgs?
So there is
and
a
get
circuit
details on that.
breaker. So there is a circuit breaker. So there's actually a bunch of circuit breaker that's defined in the spec, right? So we look at whether the parent block is missed, and then we don't reorg like the first slot of the epoch, and we also look at the participation as well. So yeah.
Gotcha. Okay. Well, let's continue that conversation in Discord. And yes, a longer test on Scar would cost multiple hundreds of thousands of dollars. So
I mean, that's not necessary. It's not that much. We could do a longer test. I wonder what would we get out of this? Like what would happen? I mean, 10 slots is already a lot. Realistically, most things that could happen due to sustained load should happen after 3 slots already, right? Like what would we learn from a 20, 30, or 40 slot tests? Someone can
yeah,
say
I
that.
guess
I'm completely
a
happy
full
to do it.
a full epoch, and then through a epoch transition might, like, that's the only kind of like milestone thing that's happening, is like, does sustained
I mean,
load
okay,
for
and
a full epoch into that epoch transition do something other than?
okay, but like the load doesn't make the epoch transition more difficult. I can see having it
understand.
in an epoch transition would be interesting, but I still don't see why the full epoch would change anything.
Yeah, I guess my intuition is that it likely would not, but that there might be like small things that compound. Like, for example, if you know you're having trouble processing everything due to delays and your queues are getting more full, random stuff like that. But I agree that the actual network component side of it should be, you know, if you're in more than 3 slots of sustained load, you're probably seeing a lot of what you expect to see.
And we can check. We might have already hit an epoch boundary. I mean, it's pretty likely since we have quite a few tests.
Right. Okay, do we have any other questions for Doncred or the data as it currently stands? We can see, to the extent the data can be opened up for a more analysis. Okay, let's continue the conversation in the consensus chat or awkward chat in Discord. Thank you very much, Doncred. Okay, anything else on Deneb for today? Great, thank you. There is an engine API versioning RFC from Mikhail.
Yep, thanks. So there is an intention to start starting from Dan Kuhn to allow for every engine API method only one version of a structure that it can accept, because having like multiple structures accepted by the same method brings an ever-growing checks and complexity to the EL side. And we were discussing this in more details during for call this week, but the question is basically some of CL clients already relies on this feature that the most recent method the most recent version of each method in Engine API supports all the previous data structures, so they can use the same method for sending for instance, for sending a payload for Paris, for Shanghai, and for Cancun. Yeah, the question is how hard it would be to break this reliance and to get back to a one-to-one relation on CL side between the method version and data structure version. So that's basically the main question for that discussion.
So I think the main reason that we had them decoupled was so that we could decouple, or so we could deprecate old methods as well as update to newer methods outside of forks. I could see how we could still deprecate old methods if we linked up the versions, but decoupling them from forks, I think, would be difficult if we enforce a one-to-one mapping.
So you mean that if any change happens between the forks, it will be difficult to switch to a new method version, right?
Yeah.
Like, yeah, the same fork supports has two method versions. Like one is, v3, for instance, the other one is v4. And when v4 is available, it will be difficult to switch to v4. Is that what you mean?
Yeah.
Okay, I see.
So you're talking about when the same method has the same actual data, so you cannot switch based on the data that you're passing, but just using the latest available method, whatever version it is, and no matter the data you're passing. So if it is data driven, you cannot switch easily to the next version of it if the data is the same. That's the problem.
Well, like we'll take the adding in of the value of the payload as an example. That was a change we wanted. So if we wanted something like that to change it, we would, I guess, presumably have a new method. But yeah, the proposal is to have a one-to-one mapping, like execution payload v2, new payload v2, execution payload v3, new payload v3. That's the proposal.
Yeah.
Whereas right now, we can have any of the underlying data types go with the versions. Basically, the versions have supported all previous data types.
Yeah, and so in order to make this kind of switch, you will have to request the available capabilities and then see that some new capability is available and start using it with the old data structure. I mean, like with the data structure of the previous version. And this is basically what you would probably do anyway, because if a new capability is added between the forks, it means that something new has been, some new data has been surfaced to CL, or some new data are requested from CL. So you'll have to anyway handle this somehow. I mean, it's not just, you're switching to v4 and sending basically the same data. That's actually how I see it.
Yeah, like presumably you could create a version, like a new method for the interim before the next fork. But that, I mean, then we would have to add a new method. Like if we have new behavior, we can't just use it right away with the method that we will use in the next fork. We would have to have a method for the interim.
Yep. And probably will, yeah. So I mean, like this does not. I mean, like having a method handling all previous data structure types, data types, doesn't seem to help much here. That's just my intuition.
What if we like didn't make this kind of a hard rule, but like so that we could in the case where we want to do something between forks, we could support two different types, but in cases where we only need to do it at the fork, then we can keep this one-to-one mapping, just kind of a hybrid. I don't know if that makes it too complex, but
I would say that we have a precedent that we're really eager to introduce something, something in between the forks, and that would be the case that we will really need these two versions supported in it. I'd say that let's discuss it by that time, but by default use one-to-one. I mean, like not making any commitments for the future, but if it will be reasonable to do this way, yeah, probably, why not? And the question for Lighthouse, do you think it will be really difficult to get back to this one-to-one thing?
no.
Okay, cool.
Yeah, it's just mostly not losing the ability to deprecate old methods and not losing the ability to upgrade independent of forks, which is the point of exchange capabilities.
I see. And yeah, about deprecation of old methods, I was thinking about it. So we can currently deprecate V1 or V2 and say that V3 handles all of those data types, but basically we're just deprecating methods, but this last method version has all the complexity that those method has. So in one-to-one, there will be just, this complexity. Yeah, this logic of validation of data types will be just lay across different methods, while with this approach that we currently have is just in one method. So I don't see big advantage of of having those deprecated while you have all this stuff checked anyway. And deprecating the data structures is really a difficult thing because we want to allow for lockstep sync since Bellatrix, since Paris. So that would be another question. Does any other HCL clients than Tequ and Lighthouse relies on this feature? Just that CL can pass whatever data structure to a new payload, for instance, to the most recent version of it. Okay, so yeah, so I think that I can make a PR if we are agreed on that. So I can make a PR to make the blob extension file specification just with one version.
But this,
Is right?
I mean, an additional complication here comes in how we actually switch over, because we're changing the behavior unless we enforce it at the Deneb fork or something.
Yeah. I mean, like this should be agreed that since I know first I guess that the new this one-to-one should be implemented in every CL that is not yet supported, and then we can plan it for some DevNet or for DevNet, because you have all those methods, all those previous methods, and you can just start using this logic that you send V1 to V1 and V2 to V2 and so forth. And then EL can just drop all these things from V3. Yeah, and what's proposed is just start to do it since V3, but V2 will remain unchanged.
Yeah, so the CL clients can switch over to this new version, and then once we're confident that all the CLs have done that, then the ELs can migrate.
Anything else on this one? Okay, so you do have that open RFC if anyone else has comments, right?
Yeah, sure. So, and I'm going to open a PR and can discuss it more if any concerns will arise.
Got it. Thank you, Mikhail.
Thank
Okay,
you.
anything else under discussion today? Great. I will put together, we're gonna have a release in the next day with these minor changes to the types in the additional field. We'll put together an issue that's tracking the handful of EIPs that we're going to build into Deneb over the couple of weeks. And we will talk about 6988 in 2 weeks. Please take a look. This is, the change to the proposer with respect to slashing. Okay, thanks everyone. Take care. Talk to you soon.
Thanks.
Thanks.
Bye.
Thanks, bye.
To everyone, bye.
Thank you. Bye bye.
Everyone.